Hello, I'm Dr. Robert Pope.
And I'm Professor Miriam Del Campo, and we're both from the Biology, Health, and Wellness Department at the Kendall campus of Miami-Dade College.
Now, today we're going to take a look at a simple experiment which will let us take a look at the process of diffusion, osmosis, and what happens as materials move across the cell membrane. This is a very simple experiment, I think one that you'll find kind of fun. In fact, it's one that you can also do at home, and we'd encourage you to actually do this at home after you've taken a look at the video that we're going to present.
For this experiment, we're going to use the egg as a model for a cell. You will need 2 eggs. You will need a jar and just a plastic container or 2, KISHORE corn syrup, and also vinegar.
As Mrs. Del Campo said, we're going to use this chicken egg as a model of a cell. But keep in mind that unlike, let's say, a frog egg, which is in the water, no shell around it, only the membrane separating it from the environment, in this bird egg, the chicken has secreted a calcareous shell around the membrane. And since we want to look at membrane transport, we're going to have to get rid of this shell. So the first thing in this experiment, we're going to take a container and add vinegar. Now, vinegar is acetic acid. It's actually about a 2% acetic acid solution, rather weak acid. But if you put anything made out of calcium carbonate into an acid, the acid will dissolve the calcium carbonate. In fact, that's what happens in your bones as you're remodeling bones. There are cells that can secrete acid and make this happen. So I'm going to take this egg and hopefully not break it. And I'm going to slip it down into my container. Now, you'll notice as I put the egg into this vinegar, you're seeing bubbles occur on the surface as the chemical reaction takes place. When you do this with vinegar, you will see the bubbles appear over a period of time. I've fudged a little bit here by using a little bit of stronger acid along with the acetic acid so that you can see what would happen very quickly. But eventually, all of this calcium carbonate will be dissolved away, and you'll have an egg without a shell. And then we can begin the next step of the experiment.
Dr. Pope showed you how to process the egg so that the shell will be dissolved. And this you should do with 2 eggs simultaneously. It will take a total of about 3 days for the shell to fully dissolve, and then what you will get is an egg similar to this one, where you have seen that most of the shell has been dissolved. You can see in this egg the shell has mostly been dissolved except for at the 2 ends, which is convenient because it makes it easy to handle. Once the egg is dissolved, once the shell is dissolved, what we want to do then is have a container with plain water and put our egg into that container. What is going to happen here is that water is at a higher concentration, obviously, on the outside of the egg, and it's going to go into the egg through the process of osmosis. All right, with your second egg, you also want to put it into a container, and this time what you want to do is put the KISHORE corn syrup to cover the egg. Now what happens is that the egg will have more water by concentration on the inside of the egg than on the outside, where the syrup is a high concentration of sugar and a low concentration of water. In this situation, the water is going to exit from the egg, and the egg should shrink. Both of these processes will take about 3 days to occur. So watch your egg closely and keep a record of what is happening.
We're taking a look at the egg that we put into our acid solution as the shell is being rapidly dissolved. Now, in your own egg, in about 3 days, you'll begin to see the pink color that you can see on the side of this one. This reaction is taking place very quickly. It's kind of like pseudo time-lapse photography, because the reason this is occurring so rapidly is because of the acid solution that we added to it. But this is exactly what will happen to your chicken egg, only in slower time frame. Mrs. Del Campo got our experiment started, and now it's time to take a look at what's actually happened. As a point of reference, we're going to use a chicken egg like the one we started with, and we'll come back and look at this closer in just a moment. But what we're going to do first is take the two containers where we had our eggs previous from the experiment and move them out. We will have one egg that's been in plain water, and we have one egg that was in corn syrup. And now we'll take a closer look at them and make a comparison. In the container on your left is the egg that we had in distilled water. Now, or I should say in tap water. As you remember, this egg was in a hypotonic solution, a solution that had a lower concentration of dissolved solutes than we found in the egg itself. As a result, water passed osmotically through this selectively permeable membrane, and the cell actually increased in size. If we look at these two eggs, I think you can see fairly clearly the original size of the egg and what we have after several days in that water solution. So this cell is taken on water. In our second instance, we have an egg that was in a syrup solution. A little messy here. But you'll notice that this cell has lost a lot of its liquid. If it weren't for that large mass of yolk in the egg, this would be even smaller than you see here. So this egg was in a hypertonic solution, and water was drawn out into that very concentrated sugar solution. Now, neither one of these situations would be an ideal situation for the cells of your body. What we would hope is to try to maintain an isotonic concentration so that the amount of dissolved solutes outside and inside the cell are equal, even though they may not be exactly the same molecules, and the cell retains its original shape rather than swelling, as we saw in this case, or dehydrating like we saw here. And this is one of the big things that goes on physiologically in your body with fluid and electrolyte balance, as you attempt to keep your cells from going to these two extremes and maintain an isotonic situation.